Hi guys, this is the fourth lesson. Let me remind you that we are talking about load testing. We have already covered the basic terms in the first lesson. In the second lesson we talk about the goals of load testing. In the third lesson we began to study the stage of load testing. The first stage was quite extensive. It was called analysis of requirements and collection of information about the system under test. And now we have come to the second stage of load testing, and in this lesson we will talk about test bench configuration for load testing. We will discuss what a load testing bench should be like. Why should be as close as possible to the real configuration, and what to do if the test bench is not similar to the real one. So, the result of load testing can be influenced by various factors, for example, the configuration of the test bench, network congestion, database fullness, and many others. The impact on application performance can be significant and not linear, making it nearly impossible to express in a formula. Let's identify those parts of the configuration that will greatly influence the results of load testing. Hardware: CPU, type, frequency, number of cores. RAM, type, frequency, size, timing. Hard disk, type, speed. Software, operating system, drivers. Network, data transfer protocol throughput, network topology. Application, architecture, database structure, software required for the application to work. Ideally, the test batch completely duplicates the work of the server on which the application is running or will be launched. But such coincidences happen very rarely in real projects, because there are many reasons. As a rule, this is a financial saving, since server capacity is expensive and the client does not agree to pay double the price for the opportunity to check on a double server that the main server can withstand the load. There are many reasons besides economic ones. For example, this could be a complex application architecture with the goal of creating a copy of it on a duplicate server. These may even include restrictions on the use of software licenses. There are also cases when the database is huge and therefore it is not practical to make a copy of it. In the end, the program may be closed as a trade secret and therefore we will not be able to transfer its copy to another server. As you can see, there can be many reasons why we cannot replicate the application under test as closely as possible on the load bench. Therefore, when creating a test bench for load testing, it is necessary to take into account such a concept as technical and economic feasibility. There are always financial and time considerations to consider, as well as the various other factors I just listed. Let's go ahead and look at this example. For example, the main server has an Intel processor, which has the following characteristics. And as you guessed, I was given the task of assembling a stand for load testing. What do I need to do? I need to find a processor with similar characteristics. I choose the one that is as similar as possible, because the one I need is only available for pre-order. For example, agree that it will not be easy to predict how these processors will behave under load, although they are similar in characteristics and price category. The same examples can be taken for RAM and for different versions of operating systems. We will not consider examples with them. I think the main idea is clear to you. When assembling a test bench, a lot of such differences accumulate, and we, as you understand, not know how the application will work based on the configuration we have assembled. In practice, it turns out that the application will be tested on one platform and will work on another. Yes, that's exactly what happens often. But how, in this case, can you analyze the results and predict the performance of the equipment in the future? There is a way out. You can use the transition coefficient, or you can use expert judgment. When using the transition rate, we take into account the numerical difference between the characteristic of the testbed and the server running the production application. In other words, we roughly determine by that percentage of how many times there is a difference in characteristics. Based on this knowledge, we can build an approximate forecast of how the application will work on the server. When we use peer review, we rely on the experience of an expert who will use our testbed data as a basis and who will usually be able to apply their knowledge and predict some use cases. What are the disadvantages of these methods? Using the coefficient, it is easy to assemble the test bench configuration at the initial stage of testing, but then a lot of time is spent on calculation using the transition coefficient. When using expert judgment, the basic configuration values such as processor type, memory size, operating system must match. Only in this case can we give an approximate, truthful assessment of how the system will work. Let's draw general conclusions based on the knowledge gained. If possible, the test bench should completely copy the server with the running application. If the test bench is different from the production one, then we cannot give an accurate assessment of the system's performance. To analyze the results with small differences between the testbed and the production server, you can use a conversion factor. At this point, that's all I wanted to tell you about the test bench. In the next lesson, we will talk about developing a load model. Bye guys.